the last day, what we learned was about the economic equivalence, the lecture number 3, economic equivalence. So we have finished that lecture with the case of the lottery. What was the most interesting thing for Lisa to have an annual installment or to have a lump sum? So depends on the interest rate. This is the key message from economic equivalence, is to know which interest rate makes two different cash flows equals today. So we tested the cash flow type 1, which was then the periodic installments, and the cash flow option 2, the lump sum of receiving today this amount. So we tested for an interest rate of 3%. We calculate the present worth of each of the cash flow, each of the installments. So, for example, for the 25th year, we calculated the present worth, the present value of this amount with an interest rate of 3%. The formula is the future value divided by 1 plus the interest rate to the 25th power. So the present value of the 25th cash flow today is worth €5. So we calculate for all the cash flows from n equal to 1 to 0 to n equal to 25. So the present worth for an interest rate of 3% is 194. So what will you prefer at that interest rate? The lump sum of 167 or the loan or the installment payments received in every year from now to 25th year? The value of this amount, the present worth, is 994 million euros. So that's because this number is higher than the option 2, the present worth of the option 2, which is 167 million euros. We will prefer the option 1, the option of installment periods, periodic installment. So the option with most preferred for an interest rate of 4.5% will be equal the option 1 and the option 2, because the present worth of the option 2 is 176 and 67 million euros, which is the same than the lump sum. So at an interest rate, both cash flows are equivalent. So that's the main message of this lecture, that at 4.5% of interest rate, the option 1 and the option 2, they have the same present worth. But if the interest rate is 6, the present worth will be, of the option 1, the installment payment, will be 145. So we will prefer today to have 167 million euros than 145 million euros. It's evident, self-evident. So that's the slide we saw, the last one we saw last day, and now we are going to start the main part of the course, which is the interest formulas for several types of cash flow. So what this lecture is the most important in this period, in this 4 lesson we have had. This lecture is the most important. What are we going to see here is what is the present worth, the present value, or the future value of any kind of cash flows. So we are going to know what are the formulas behind the calculation. So let's start. We will start distinguishing several types of cash flows. So we can distinguish the single cash flows, a single cash flow, or we can distinguish the uneven payment series or equal payment series or gradient series. What is a single cash flow? A single cash flow is in certain time, and for example, we will have a single cash flow, just a cash flow in certain year or certain time instant. What we can do with that single cash flow is to know the present or future value. Do we know to calculate this present or future value? Yes, of course. It's what we have been doing in the previous lectures. The present value and the future value is the present or the future value multiplied times the 1 plus a to the interest rate times, to the nth power, or depending if we are calculating the present value will be divided by that factor. What is an uneven payment series? A series of different receipts or disbursement in several n, with no clear pattern. So today we have a receipt of 10 euros. In 1 year from now, we have a disbursement of 30 euros. And in year 2 from now, we have a receipt of 50 euros. So no clear pattern and different signs, receipts or disbursement. We can calculate with a formula, we can calculate the present worth of uneven payments or future savings. Do we know to do that? Yes, of course. Is what we have done in the case of, for example, Lisa's lottery, the last example of previous lecture. We estimate, we calculate the present value of each of the installment payments received by Lisa in the installment option lottery installment option. So we know. Where do we find this kind of uneven payment series? In which kind of real situation? In United States, you can pay in advance your university fees. You can pay for the next 4 years. You can pay in advance, and avoiding the possible and future increments of the tuition, the fees, and then you pay today and you avoid that risk of probable increase in price. So you pay in advance, of course, a big amount. So that's uneven payment series is the way to calculate, because the tuition fees can change every year, and then it's not a constant payment every year in the next 4 years. So this is what we can use for estimating that option. What is an equal payment series? A. We call that equal payment series as the periodical payment every year or every month or every year of, no, I mean the payment or the receipt. If we are receiving money or we are paying money, always the same amount. So in that sense, this is a series of uniform payments. A long payment. Which kind of real things are similar, are equal to this type of cash flows? For example, when you have saving account, and then you deposit in that saving account the same constant deposit. Or for example, when you have a loan you have bought a car, and then you have a loan, or you have bought a house and you have a mortgage, which is a loan for houses, and always you pay the same amount. This is a series of uniform payments. What is a sinking fund? Is another real situation. In that case, is that we are creating a future fund. We are saving today for having in the future certain amount of money. So we want to make those savings, and then we every month or every year we save a fixed sum we deposit in each interest period. This fixed amount is A. So if I want to have 100,000 euros in 10 years from now, so I make the calculation, and this economic engineering calculation will say that you have to save and you have to deposit every interest period, every month or every year, an amount of, for example, 2,000 euros. So this is quite used for college in our environment of university, for college savings plans, or in business, in companies, they make savings for future to replace a machine, a fixed asset. What is another application is the capital recovery. Also, we are talking about the periodic payment A and a fixed periodic amount, which is A. This is a series of payments for fixed amount and specific for a specific number of periods, and is the amount we are paying when we pay off loans. So that is quite common. What is the present worth factor is the question we can answer with that present worth factor is, what would you have to invest now in order to withdraw 8 euros at the end of each of the next n periods? So imagine you want to save some money for the future, and then you estimate in the next 5 years you want to live 1 year as a sabbatic one, don't working and going around the world or traveling or just staying at home, and you want to live 1 year without working. So you say, how much money I need every month? I need 600 euros, for example, to live. And then how much money I have to invest today for in order in 5 years from now I will be able to withdraw during the next 12 months to withdraw 600 euros per month. Another kind of cash flows, a particular case, is the present values of perpetuities. What is a perpetuity? Perpetuity is a stream of cash flow that continues forever, so never ends. And the gradient series we are not going to see because they are quite complex, and then we can use Excel to reproduce that kind of gradient series. This is periodic payments that are not uniform. They increase. This is not always A every month. Those gradient series is a periodic payments that increase or decrease by a constant amount G or a percentage of growth. For example, you can say, I'm going to save every year 1,000 euros, and every year I will increase that 1,000 euros in a 4% in order to avoid the inflation, for example, inflation rate. So let's go to see what are the formulas. Let me see if there is any question in the chat. Hello, Ignacio, good morning. Okay, so no question. And then we have here a summary, a table trying to summarize the different formulas. You see here the previous table we have seen, the single payment case and the equal payment case. So what are the different situation we can face in the case of single payment. Sorry, excuse me. Here we see also the uneven payment. Okay, let's go to see the single payment, which are the first 1, 2, 3, 4, the first 4 rows. We know the formula for compounding. So we know the present value, we know the number of periods, the term of the investment, we know the interest rate. What we don't know is the future value. And also, there is another variable we can consider in this kind of payments, this kind of formulas, which is the periodic payment, the A. So we see here in this table the name of the operation, of the single cash flow or equal cash flow, the formula, and the Excel function, the Excel financial function that solve this situation. And we see here 1, 2, 3, 4, 5 columns, which represents each one the different parameters of those formulas. For example, the F is the future value, the P is the present value, the I is the interest rate, the N is the term of the investment, the last period, and the A is the periodic payment. So in single payment, all the rows for single payment from row 1 to row 4, we see that the periodic payment is not considered. Why? Because we are talking about single payment. We are not talking about equal and periodical payment, as will be the case in the second group, the green one. You see here, the periodic payment is always something that we know or we have to know. Okay, so what does it mean in that table? The hyphen. The hyphen, it means that we don't need. We don't have to consider that. So if we see here an X, this means that we know the present value, we know the interest rate, and we know the term. What do we know? Why we don't know is in that formula, compounding, we don't know the future value. So the formula, this one, tells us how to estimate this unknown value. So the future value, as the Excel formula says, the future value, you have to write the interest rate, the term of the investment, 0, because the payment, the periodic A is 0. Using the sign minus for convention, minus, or you can put here in front of future value, and then 0, which is the method. What is the formula for the conventional engineering books? I haven't showed you the engineering economics book I use as a guide, as the guide for the course. This is the fundamentals of engineering economics. I don't know if you see. Okay, you can see the fundamental of engineering economics. The teacher is this teacher from the United States University, which is Chan A. Spark. And this book use, and all the other books we can find, all the books on engineering economics, all they use this kind of expression. So future value is equal to the factor P. What is the factor P? The factor P is the variable we know, P, and then you have to write here, and then there are big tables in the annex of those books. We are using Excel, so don't worry about that. But for example, in this book, you can find, I'm sure you will not see them, but you can find here big tables with the different formulas of F, P, and others, depending on the interest rate in the number of years and then they give you the factor you are going to multiply the present value or the future value. So what's the case of knowing the present worth of a future single cash flow? As we know the future, we know the interest rate, we know the number of years, but we don't know the present value. So what is the Excel function is present value. In Spanish, as you know, will be valor VA. But we can solve another problems. For example, in single payment, we know the future value, we know the present value, we know the number of years, but sometimes we need to solve for I. So what's the interest rate that makes a future value, or excuse me, a present value equal to a future value? What is the interest rate? This is the kind of the kind of problems we solve with economic equivalence, as you remember. So that formula in English, in Excel, is rate. In Spanish will be tasa, rate. You can find in internet, in Google, the translation from English to Spanish of the Excel financial formulas. Just look in Google or anywhere else. So we can calculate here the interest rate. Or also we can say if to solve for n, for the length of the investment. So for example, we want to know how many years I have to deposit, or I have to wait until until in my account, in my saving accounts, I have 10,000 euros if I save every year 1,000 euros and the interest rate is 5%. So I know the future value, 10,000 euros. I know the present value, I'm going to save 1,000 euros. And then I know the interest rate, and I want to know how many years I have to let this amount of this present value in order to get in the future 10,000. So that is the end period. An even payment. How do we solve? We know the formula is applying the present value formula to every future value. So if I have future values, for example, in year 1 of 10, in year 2 of 100, in year 3 of minus 200. So how can I calculate the present worth of those payments? So applying the discounting formula, not the compounding, the discounting. What happened with equal payments? With equal payments, we see here, as I said before, that we have periodical payment, equal payments of an amount A. So we see here that all this table, we know, or we have to know, the value of A. So for example, we see here 4 rows, 1, 2, 3, and 4. What does it means the first 2 rows, and you see here a cell, a joint cell for compounding and for sinking fund, and in this cell is written with F. What does it mean? That in all those cases we don't have any present value. So let me see in advance later to explain what is that. So for example, compounding. So I'm depositing every month or every year and a payment during n years at an interest rate of 5%, and I'm starting to save not today, I'm starting to save 1 year from now. So the present is 0, is no, it doesn't exist. So how much is the future value? The future value, we have a formula, we know the future value of AN minus A, which is the payment, periodic payment. As we have seen the previous on the previous lecture, we used A as equal to 0, and now A is not equal to 0, because we are in the case of equal payments, and then 0, which is the type of calculation for Excel. What is a sinking fund? A sinking fund is, if I want to have a future money, for example, 100,000 euros for my kids when they will go to university, I want to have 10 years from now 100,000 euros in my account for paying universities, or I don't know. So I start to save the next year. I don't deposit any amount today, and I know the interest rate, I know the number of periods, the number of years. So how much I have to deposit every year in order to get this future amount? So this is a sinking fund. Or, for example, we can use this one. Okay, we'll come back later. And what are the kind of problem we have to we can solve with the present value of with present value? In that case, the future value of the investment is 0, as you see. The future value is 0. So, what is the present worth of a periodic payment in the next nth year at an interest rate of I? So we can calculate here the present value of this investment. The present value formula in Excel, we see here. What is the capital recovery? Is solving for A. So we have here the capital recovery formula. We see here that the future value is not necessary. The present value we know, the interest rate we know, and the number of years we know. How much I have to pay every year, every periodic payment? So that's the capital recovery is the kind of calculation we can use to know how much I'm going to pay for my loan. If I receive today a loan, I know the present value of the loan, 30,000 euros for buying a house, or a house or a car, and then I know that this is for 5 years. I know the interest rate is 7%, so I want to know how much I'm going to pay every year. So that is the capital recovery. Okay, so as you see, this table can be read, those columns as, for example, the formula F equal to the P factor of FPIN is read like that. Find F, given P, I, and N. So we can find through Excel formulas, through tables in the books, or as I will suggest you will be an advanced economic engineer, to use this kind of calculators. I have one. This is the Texas Instrument BA2 Plus Professional. You see here, have in my hand, and you see here in the slide, we have different ways to solve the problems. One is the direct formulas. So present value times bracket 1 plus a to the nth power. We have tables in the books, or you can construct tables in your Excel. And then what we find in those tables is that, for example, the factor for compounding a present value and to calculate the future value. For example, I see here in the table that for 5 years in the year n, so I'm looking here in this table the value. I know you don't see, but I'm going to explain. You see here the single payment factor for compound factor, so you are going to calculate the future value of a present single payment. Present single payment. For example, in 5 years, I see here the compound factor is 1.1041. So if I have, this is the interest rate of 2%, the table, and you have a page for every interest rate. So if I save today 1,000 euros, and then I want to know how much is worth in 5 years from now, n equal to 5, at an interest rate of 2%, I will look into these tables, and I will find the compound factor, because I'm trying to know the future value of a single payment, and the value of the table is 1.1041. So if I multiply the present value, 1,000 euros, times this factor, I will know that the future value of 1,000, the present value of 1,000 in the future, in 5 years from now, at 2%, will be 1,104.1 euros. So that's the use of those tables. And the third methodology is to use financial calculations. So in those financial calculators, there are two which are quite known: the Texas Instrument BA2 Plus Professional and the Hewlett-Packard 12C Platinum and Prestige. And you find here keys, some keys. In the case of this, the BA, the Texas Instrument, you find the second and the third row of keys are especially dedicated for financial calculation, for time value of money. So you see here, I see the fonts in the computer, because I have the fonts of Texas Instrument, and those mailbox you see here in my PowerPoint, and I think in your PDF. Yes, in your PDF you see the right signs, the right keys. But the fonts on this computer of the UPN, they don't have the fonts of Texas Instrument. So what you see in your slide is the key N, which is to enter the number of periods. The key IY is to introduce the interest rate. The key present value is to introduce the present value. The key PMT is the same as periodic payment. That's the word PMT, payment, is the A we have used it, and the key future value. So you have always 5 values, as you see here in the calculators, and then as any kind of equation, you have to know 4 of the parameters, and then that calculator calculates for you the unknown. And also those calculators, they have keys especially devoted for the cash flows, and also they can do more specialized financial calculation. We are going to see in the next period of lesson, which is the net present value and the internal interest rate, the NPV key, and the IRR key. And the fourth option, that is one I'm going to suggest you, is using the spreadsheets like Excel or Google Drive or any other. Okay, but what is my advice is any methodology that you're going to use is trying to understand the mathematics which are behind the Excel and behind the calculator. So I will suggest you trying to learn the direct formulas, because it's the only way you will understand what are you doing. So in your first month or your first calculation, please try to use the direct formulas to be aware of the complexity of the problem, or to know the nature of the problem. And then when you have further knowledge of the subject, you can go ahead with the spreadsheets. Also, with the spreadsheets, you have the option, two options. You have the option of using the internal financial function that we have seen that Elsa's provide, but also, and I prefer this second way, is you yourself introducing the formulas in Excel, as you will be in the case of direct formulas. So, for example, if I want to know the present value of a future cash flow, you can write in Excel the formula, and below, under the future value, you can write the present value formula, which is equal to the future value, which is over the cell you are editing, divided 1 plus, and then you go to the interest rate cell, to the nth power. So you create in the upper part of your spreadsheet an index from n equal to 0 to 1, 2, 3, 3, and then you can make the nth power in every formula. So I prefer doing that with Excel. So I don't like Excel function, because I don't have I'm not sure of the use of them. So I think it's preferred to use to program the Excel to create your own formulas in Excel through the direct formulas, but not with your pencil, but with Excel. So any question until now? Okay, Ignacio. So let's advance. So you have here, according to this book, you have here the different formulas. So for single cash flows, the compound amount, as you know, the future value is equal to P times 1 plus A to the nth power. In the Excel, you have the cash flow diagram. So either we know the P or either we know the F value. So we have to know, and we know the interest rate and the nth, the term of the investment. So we can calculate the present value or the future value, depend on the case, the compound amount or the present worth. So what happened, and this we have seen before, the compounding process, find F given P, I, and I. So given P, N, and I, to know the future value, we know to calculate is the present value times 1 plus I at the end. So you can read, of course, by yourself. As you remember, we named this process to capitalize, to project, or to compound. For example, if you have today, this is a misprint. If you have, today 1,000 euros and you invest it at 7% interest compounded annually, how much would it be worth in 8 years? So we apply any kind of formula, direct formula, the table in book formula, looking for the factor in the tables, or also using the Excel formula. You can programmate the Excel with this formula. I prefer doing that. Okay, all of them, they give us the same result. The future value is 718.19 euros. So the discount process, we are still in the single payment cash flows. The discount process or the present worth is find P is unknown, given future and I, of course, and N. So we know the future value, and then we want to know the present value. The formula is the discounting process. We know the discounting process. So if you want to have these kind of things can be solved with the present world. If you want to have 20,000 euros in 5 years, and you have a bank proposal for a deposit in a savings account at 3.56% interest compounded annually, how much money would you have to deposit today in the account? So you want to know to have 30,000 euros in 5 years from now at an interest rate of 3.5%. What is the amount I have to deposit in the account? The present value, we can use this formula, the present value equal the discount formula. Discount formula is P equal to the future value divided by 1 plus I to the nth power. You can use the tables, factors, and the third methodology, of course, your financial calculator, and then the fourth method is the Excel, and then all the methodologies give the same result, which is 25,259.20 euros. Okay. And another problems can we solve with single payments, as I have announced, is solving for I. So I want to know what is the interest rate given present and future values and n. So for example, if you have today 1,000 euros and you want to have 1,250 euros in 5 years, what is the minimum interest rate will you require to any financial assets? So you have the present value, you know, 1,000, you know also the future value you want to have, which is 1,250 euros, and then you know the term, the number of years, 5, what is the interest rate. You can solve this equation, you can clear up I, and then calculating this I. So as you see, this calculation is increasingly complex than previous because you have to clear up I, which is under a bracket and to the nth power, or also you can use the Excel rate or the financial calculator, just pressing the IY key. So all these formulas, all these methods gives the same result, 4.56%. So as you see, this is quite direct calculation, and solving for n, find the number of years given present and future values and I. So if you have bought today 1,000 euros in Shell shares and you want to sell them at 1,500 euros, once you have estimated that the sell stock price grows at 8%, the compound annual growth rate, what is the number of years you have to keep your shares before selling them? So you have 1,000 euros in Shell shares today. You want to have in a future, you don't know when, the number of years, you don't know. That's what you want to know. You want to have a future value of 1,500 euros. You know that the interest rate is 8%, so the value of those shares grows 8%. What is the number of years you have to wait until selling your shares? So that is the number you can find here. This is making the inverse root of n. No, clear up here n. All of you know, and then in n is equal to 5 years and 3. Okay, you know this is decimal number, and the number of months is 12, so you have to adapt to the number of months. So that's the kind of things we can do. Let's go for the more complex formulas, which are the equal payment series. Okay, you see here the representation, the table that is provided by this textbook, and what they use different situations. As you remember, the equal payment series, we are going to use the cash flow diagrams. They are quite useful, cash flow diagrams. I suggest you always trying to express, to draw those cash flow diagrams in order to understand what the problem is trying to tell us. So we, in those cases, as you see here, we don't have any present amount. We don't have any value at zero. Our target, our objective is finding either future value or either the A periodic payment. So as you see here, we have two different problems. One is, what is the future value of a periodic payment of A during end periods at certain interest rate? So the future value is equal to this formula, F equal to the A payment period payment times big brackets 1 plus A to the nth minus 1 all divided by interest rate. This formula can be derived from the summation of, you see here, the future value. We know how to solve directly, will be the summation from from key, for example, the letter key, equal to 1 to n of A times 1 plus interest rate to the key, the summation factor, which is key. So if you develop this summation, you can derive this general formula without doing the summation. You know, any arithmetic or geometric progression, it has at the end one formula. The Excel command is this one. So with the compound factor, we know the future value of periodic payments. All those cases, we don't have any present value. We don't have any, we don't deposit any amount today or invest any amount today. What is the sinking fund? The sinking fund formula is to know if I want to have a future amount of money, how much I have to save every month, A, in order to get at the end the future value. So A is equal to, and then you see here the formula, and the Excel formula is PMT with the correct parameters. We are using this formula, the sinking fund, for example, to know if I want to have the case I say savings for your university, for the university of your kids. You want to have 60,000 euros 10 years from now. How much I have to save today, not today, from the next year, the periodic payment. At the end of the 10 years, how much I will have. This is the future value, I know, and then I have to know, I want to know the periodic payment I have to save. What is the other, and this is why this table is divided with this straight line. This case is different from the two previous one. This case is I know or I want to know the present value, and we don't have any future value. We don't have any future payment or future value. Our worry is to know the present worth or to know the A payment for having a present worth. So this is the formulas, the factor notation, the present worth. In that case, I will calculate the present value of future payments. So for example, this is used as the case, as I told you, my sabbatic year. How much I have to save today in order in the next 5 years I can withdraw from my account 600 euros every month or 6,000 euros every year. So how much I have to save today? This is the P factor. The other case is the capital recovery, is I know the present value, and I want to know the amount of money I will be paying for that present value. So this is the case of loan or mortgage. When we buy a car or we buy a house, we know the amount, the present value of the loan. For example, if I ask for a 30,000 euros loan for buying a car, I know this, and then with this formula, I can know how much I'm going to pay every year or every month, and so on. So as you see, those formulas are quite common and quite useful. You see here different situations that we find the formulas for equal payment series. For example, transactions in which an uniform series of payments exists, like for example, rental payments. So for example, you don't decide to buy a car and you prefer to rent a car, or the leasing of a car, or for example, you buy a bond, you sign a loan, you write a loan. For example, our concern in this kind of transaction is to find the present worth of any uniform stream of payments, or the future worth in that case. So we find the present worth of each future amount, discounting it at interest rate, and depending on the n, because the n power, and then finding the present worth by assuming all the present value of every year, as we have seen several times. Applications, you see here, for example, the equal payment series, the compound factor, the case of compound amount. So you save or you deposit in your account every year what will be the future value? So this is making annual contribution to a pension plan. So if I want to retire with 100,000 euros, how much I have to save every year today? If the interest rate is 3% and I have 20 years ahead until that retirement. Or for example, the sinking fund for college savings plans, or replacing fixed asset, as I told you. I know the price, the future price of university, for example, or the future price of buying a new machine. So I want to know how much money I have to save to obtain that final amount. So given, and then in this case, always we are thinking about the future value of things. The other two cases was trying to find the present value of things. The capital recovery, for example, paying off a loan, which is to know I know the present value of the loan, how much I'm going to pay every month. That is the capital recovery. So, for example, the compounded amount factor, which is, we are talking equal payment series. What is the find calculate the future amount you will have in a saving account if you deposit 1,000 euros at the end of each year during 5 years at 3.5%. So you can do, as I suggested you, with an Excel file. You have here the beginning balance and you have the ending balance. So today you don't deposit any money, but at a certain moment in the next year you deposit an A payment of 1,000 second year, 1,000 third year. So at the end of this year you have because you did the deposit at the end of year 1. You don't have any interest payment. The ending balance is the same amount, you did periodic deposit of 1,000. Then next year you start with 1,000. You are paid at the end of the period the 3.5%, which is 35. And then at the end you also deposit the new A amount. So you have all this sum at the end of year 2, 2,035 euros. So the interest rate of 235 euros at 3.5 you have here calculated. So at the end, the future worth of this amount is 5,362 euros. So note please that you make deposits at the end of the year. The interests are paid on the beginning balance amount. So the interests are paid based on the beginning balance amount, because you know interest rate is the cost of money and over time. So in 1 year you need that year happens. No. If we find the future worth, this formula, applying the future value, the result is the same as we have done step by step. So you can see, excuse me, okay, here. I'm going to open the Excel. Let me, okay. So this is the calculation is here with the manual or handy calculation. And this is the Excel calculation with the financial formula. Is the future value of the rate 3.5. As you see here, the colors are quite useful. The green cell is this one, the number of years, number of periods. The payment, the periodic payment is 1,000, this one, 1,000. And then actual value is 0 and type is 0. So directly, without any kind of programming, you will find the Excel formula here. Up to you, of course. This is more didactic. This way is more didactic, but is slower. No? The Excel financial formula is a direct one. It's quite quick. And okay, I suggest you to use later when you master the engineering economics. So this is any question? Is there any question? Hello, Alejandra. Okay, so let's have a break, 5 minutes. We will come back at 12 minutes past 1. So see you then to the lecture. We were learning different applications of the equal payment series. We have seen the compound amount factor is find the future value given a periodic payment A, the interest rate I, and N. We use it, for example, for pension plan. Your bank offers a pension plan. It consists of depositing depositing 3,000 euros every year for the next 40 years until you will be retired. The bank offers a 3.5% annual interest rate. How much money will you have at your retirement age? And you see here the cash flow payments is 3,000, periodic payments. So at the end of 40 years from now, you will have 2,500, 253,625.51 euros. So you can calculate with different methods, and of course with the future value of Excel. You see here how is this formula. In the case of Excel, you see here, this is future value of the interest rate, the blue cell, the number of periods, 40, the green one. The periodic payment is 3,000 euros. The actual value, the present value 0, and the type 0. Okay, so it's quite straight. What is the sinking fund factor? So what we know is the future value of our money. I want to have 100,000 euros in 8 years from now. How much I have to deposit every year at 3.50% of interest rate. So this is what we call the sinking fund. Is find A, the periodic payment, given the future amount, the interest rate, and N. So a college savings plan. You are planning your future needs for financing the college of your daughter. She's currently 10 years old and will go to college at age 18. You think she will need 100,000 euros for paying college tuition fees and living costs for the 4 years she will be studying. So you want to have 8 years from now 100,000 euros. How much do you need to save each year in order to have the necessary funds if your bank offers a 3.5% annual interest rate? So you see here the cash flow is every year. The next year you deposit 11 a periodic amount, the second year also the same periodic amount, At the end we know that we want to have 100,000 euros. So how much is this periodic payment? This periodic payment is the A, and this is 11,048 euros. How do we calculate? With the formula of payment. In this case in Spanish is pago. You see here the interest rate in blue, 3.5, the number of periods D, 8. This is the current value, the present value 0. We are not saving this year, today. Not this year, I mean today. This is the future value. We know that we want to have the future value, which is 100,000, and the type of calculation, as always, 0. So that's the way of calculating this one. For example, capital recovery factor, the annuity factor is, we are now leaving the future values and then we are trying to handle the present values. So this case, the capital recovery factor is find the A payments given present value, interest rate, and N. This is clearly, this is the amount of periodic payment you are paying when you get a loan. So the annuity factor indicates a series of payments of a fixed amount for a specific number of periods. For example, paying off a college loan. You have borrowed 60,000 euros for paying the tuition and the fees of your MBA in Barcelona. So you have borrowed from the bank 60,000 euros. So you plan to pay it off in 7 years from now. The business school offers you a 3% interest rate. How much will you be paying annually? So you know the present value of the loan, 60,000 euros, and you know the interest rate of the bank, and you know the loan, and you know the number of years you are committing to restore the initial amount. And then the periodic payment will be calculated with the capital recovery factor, and this is 9,630 euros. just a matter of reflection. Is an MBA worth if you would increase your potential annual salary in 15 euros if compared to the non-MBA engineer? So if you do an MBA, you will earn 15 euros more than a non-MBA engineer. So how much does this MBA cost to you? 9,630 euros. So I think it is worth, definitely, because you are earning more than the cost, which is 9,000. What's the formula? You see here, which is the periodic payment, is always the formula payment. You see payment of B5, which is the interest rate, the number of period 7 in green, and then the future value, as you see here, is always 0, and the present value is the loan, the amount you are borrowing. So as you see here, all the cases are quite straightforward with the Excel. The present worth factor. So find the present value given a periodic payment, the interest rate, and the number of periods. So that's the case of a sabbatic, for example, of a sabbatic year, as we have told. Or, for example, if you want to secure your son's college fees. For example, you have a son, 18 years old, and you want to secure him that in the worst case, he would be able to pay his college expenses, which are 18,000 euros per year. He's starting now the college at the degree, and the degree is 4 years. So the bank offers you a 2.5% interest rate. How much do you need to deposit today in your savings account today? So you have the cash flow for the next 4 years. You want to ensure that your son will have 18,000 years every year. So how much you have to save today for in order to satisfy these future needs at the interest rate and the number of periods? So this amount, you have to deposit today 67,000 euros and 716. So this formula is the present value, of the interest rate, of the number of periods, of the periodic payment, in that case 18,000, the future value, is, as the previous case, is 0, and then the type. So is there any question? Okay. And then okay, that's a reflection out of the main lecture. But are the Spanish families prepared to finance private university education? That's a quite actual discussion theme. So that's a big amount of money, which nobody probably, or just a few people, just a few families have. Okay, perpetuities. What is a perpetuity? It's a special type of cash flow. It's a stream of cash flow that continues forever. So, for example, the famous preferred shares of banks, like for example in Spain, Bankia, or different savings banks. They offered customer buying preferred shares with the promise of paying them every year a fixed cash amount, and these preferred shares never mature, so never disappear. The problem with those preferred shares has been that the banks, some banks, they have cancelled the payment, and they have forgotten their obligation or the commitment with customer to buying at a certain price those preferred sales. You cannot, the problem with this special type of cash flow is that with perpetuities you cannot compute the future value of this cash flow because it is infinite. It's infinite. So from key equal to 1 to infinite. However, we can calculate the present value. In this way is how the preferred stock are priced. So we calculate the limit to infinite of the series, and then the present value of a perpetuity is equal to the periodic payment you are offered divided by the interest rate. So for example, you are offered a preferred stock of General Electric. This is a big American company. General Electric says that they will pay you every year $1.5 every year in concept of fixed dividend. So your bank tells you that the interest rate you will get from this investment is 3.5. How much are they priced today? So we know the periodic payment, $1.5. We know the interest rate, 3.5%. So what is the price? We use the perpetuity formula. Is the A divided by I. So this is 1.5 divided by the interest rate. So the price of General Electric preferred sales will be $42.86. What happened with an event payment series that you see here, as we have shown before, we have talked before, it's quite not clear pattern over time. So we can calculate the present value today. The present value is the summation of all the present worth of each payment. For example, your first engineering economics engagement. You are working as engineer in a consultancy project for an industrial client. Your working team has developed the future cash flow which will generate the project of investing in a new power plant, and they ask you, your colleagues ask you about finding the present worth of them. So what is the profile? What is the cash flows? What are the cash flows? We see here in year 1, 20, in year 2, 25, in year 3, 12, in year 4, 5, in year 5, 40 euros. How do you calculate the present worth of this uneven payment series? Just calculating the present worth of each one of the cash flows. Oh, let me see what happened here. Let me see, because this number I don't like. This is the BC, and then the number of period 1, G1, G1. No, I think this exercise is wrong. C2 payment. Oh, I have to say that this exercise is wrong. Why is wrong? Can you guess why? Because we are trying to know the present worth of those cash flows. So, for example, the present worth of cash flow in year 1 is equal to the present value of the rate. Of course, is good. The blue, the B5. And then the number of periods is not. The number of periods is not 5 because we are discounting for the year 1. The number of period is the same cell C1. I will explain later what is the dollar sign here. Is the blocket, the insert key, what is? Okay. So the number of periods for discounting the first year of cash flow, the number of periods is 1. G, not G, C1. This cell, okay. The C1 cell, this one, and then the payment is not C2, the payment is 0. And then the future value is this one, the cash flow of year 1. So, okay, like back match this one. Very good. So I will drag this formula to the rest of the row. Okay, I like that. The result is that one. I hope you have understood what was the problem and the solution. Excuse me, what is the meaning of dollar in an Excel formula? I will clarify if you don't know. When I drag this formula to the right, you see here, if you compare the C3 cell with the D3 cell, you see here, when I have dragged, that this formula has been iterating the letters and the numbers that I haven't put a dollar in front of them. So, for example, I have put a dollar in front of the B and a dollar in front of the 5, which is the interest rate. The B5 cell is the interest rate. And then if I drag to my right this formula to extend the formula to this cell, if I don't use the dollars in the Excel formula, this will change when I drag. The B will become a C, and depending if I drag downwards, the 5 will iterate to 6. So as we see in the formula of cell D3, we see static. The B5 cell is static. It hasn't iterated in. So it was what I wanted, that the interest rate formula is always for all the cells. But you see here, the cell C1, this is the cash flow. This formula, I want to iterate. I want that this C1, if I drag the formula to my right, for the next cell, it will be it will be D. When I drag to the right, it iterates with the letters. Okay, so as you see here, for the second year cash flow, this is not C, is D. So what is my target? And the same, of course, for the index I'm using. The index I'm using is D1, the first row, and the second row is for cash flows. So that's the reason. Any question to that? It's just a trick. Okay. Come back to the slides, number 44. So please write in your slide the right numbers of this row, the present worth of every n. GR1 is 18.8, GR2 is 22.0, GR3 is 9.9, GR4 is 3.9, and GR5 is 29.2. And summing up all those terms, the present worth and the correct solution is 83.8 million euros. The gradient series of cash flows, as you see here, as I told you before, the periodic payment is not uniform. Now the periodic payment grows at certain rates. For example, this is duplicates and the triple 4 times, and in that other case is a constant growth, for example, for 10%, 1 plus G. So that is the complicated formulas. The best way in your professional life is apply worksheet model. We are not going to see them, but you will find in textbooks. So you see here a summary of the different problems of time value of money. We have seen the single cash flow, for future value, for present value, for finding N, find I. For equal payment, the compound amount, the pension plan, the sinking fund for savings for college, the capital recovery, paying off a loan, or the present worth, save now for periodical withdrawals, all the uneven payments. So that's a summary of this lecture. Is there any question? It's all clear. Thank you, Ignacio.